Welcome to the Wingly Update, name to be decided. Forget everything you know about programming language for the cloud. Now, welcome your host, Eyal Keren.
Hello, Merry Christmas, Happy Holidays. We are live from Tel Aviv, and welcome to the first edition of the Wingly Update, named TBD. The show that might launch my career into a new high, or maybe something that I will forever try to remove from Google indexing system before I join it. Today, we'll be covering the following items. Some breaking news about Wing and the highlights from the community from Revital. Thank you for joining us, Revital.
Awesome to be here.
Seeing Wing take off with Elad Ben Israel, an above and under the hood discussion. Why a new language? A deep dive with a language agnostic language expert. And let's start with those major announcements. The winglang Hello W. Attention all consult users.
All millions consult users.
Yeah, that's that part. I can
We
probably
have millions
name
of them.
Okay, but attention, feel those if you're listening to us.
One or two.
The team has just released a major update that is sure to change the game for you. We're introducing winglang command, which allows developers to really go into flows. This command watches and compiles your source code, and the code source is updated in real time. You can view your application architecture as it gets built, and even more, play with it and test it, all locally. You want to see this in action, Because you already showed us how it works. You can head down to winglang.io YouTube channel and check out the demo that Revital has made for us. But before we move to the other announcement, we have great timing here. I see that we have Bear coming, Shai. Please, come on. This is kind of a surprise. Thank you for joining us. This is kind of a surprise for Bear. Bear is our Chief Marketing Officer.
Acting chief.
Acting Chief Marketing Officer. And he's sponsoring this event, this talk show.
No,
Listen, this is we're live. We're live.
Oh fuck.
Oh no, in English and PG-13, please.
Oh shit. Oh no.
So you probably want to say some good things about the show?
I don't know. You told me you're just gonna record some short videos with your iPhone and a cardboard behind you, and what the fuck?
The show. This is something that we've talked about, right?
Not really.
No. Okay. So I'm sure. In fact, do you mind switch to make it back? Switch. I want to thank acting. Okay, so he's a good guy. He will come around after we see the shows. I'm pretty sure he's. I'm pretty sure he will come around. He's a slow learner. Let's go back to the announcement. So the next item might bring grief to some of you who've been using our system for a long time.
Again, all of our millions of users.
And we are talking about a very long time for this thing to be up. But the decision to use the tilde sign for the function modifier indicating in-flight code blocks will be rolled back. That's right. No more tilde sign for in-flight functions. But let's take the opportunity to remind everyone, especially those who kind of are my friends and are electrical engineers, don't know anything about that. What is in-flight all about? The in-flight function is a modifier that allows you to execute an isolated code blocks on the cloud, which means Lambda functions, Google Cloud Functions, containers, pipelines, anywhere in the cloud. You take a function, you add the in-flight function, our compiler and our language basically makes sure that everything is legal, that you can use the right kind of serializable stuff. And then it can run on any of these platforms. Until that change, and we're talking about version 0.1 to version 0.2, you could have used the tilde instead of in-flight, but the in-flight keyword is now explicitly required. Does that make sense to you?
Mm-hmm.
Yes. Thank you again for being here. I need someone to interact with when I'm having this thing. So our next item, one that you will love, our community has named itself. Yes, well, it's official, guys. After weeks of heated debates, endless posts, and far too many ChatGPT sessions to count, we finally settled a name for ourselves. Drum rolls, please. Are we the Wingwalkers? No. The community members will henceforth be known as Wingnas. Now, before you start sharpening your pitchforks and lightening your torch, and yes, I'm especially talking about you, Revital, and your pocket of resistance, formerly known as the Wingsters, let me explain. I acknowledge that it's not the most conventional of names, but I think it perfectly encapsulates the quirkiness and individuality that can make this community unique. We may be a little nutty, but we're proud to fly our Wingnuts flag high. Onward and upward, Wingnuts. And that's really good segue to kind of talk with you, Revital. And so Revital is our community manager, and she's here to talk to us about, to tell us a little anecdote about the community. So, Revi, what do you have for us today?
Hi, Al.
Hi.
First of all, I love the show.
Thank you.
Awesome work.
Wait, I'm sorry. I'm the electricity guy. I'm sorry, I love wind. I think your microphone dropped.
No.
It dropped. Oh.
Yeah?
Yep.
Yeah. So, I'm sorry.
That's quickly, I'm not sure. Okay, let me try. You're the electricity guy? Why are we paying you so much?
Because I also do sound.
Okay. So let me bring it back. So,
Amazing.
oh, nice. So do we start over? No.
No.
Thank God for that.
Like that. Just a second. Real good.
We're good? The electricity guy. This is,
Okay,
I was saving this.
you introduce me again now.
Okay. So I was saving this for if I get sweaty. So I need to introduce you again, so I don't need the teleporter to go back, but thank you for doing this. So Revital, our community manager, she's here to tell us a little bit about a specific story and anecdote from the community. And Revi, what do you have for us today?
Okay, so I want to talk about the community. Are you surprised?
I'm not surprised.
Okay. So specifically, I want to talk about something that I want to put on the spot, a very nice and fast iteration cycle that really highlights the power of the community.
Of the Wingnuts.
Of the Wingnuts.
Yep.
And the Wingsters.
Okay.
But the Wingnuts.
Gail can handle the...
So it all started with a very innocent Slack comment mentioned by, do you guys have drums here? Corey Queen. So he was pointing out that in order to open our Wing console, we shouldn't just use the winglang command, but instead we should be using, are you ready for this?
I'm ready.
The wing it command.
Wing it command.
Isn't it super cool? Wing it, and the console is opened. So later on, a few seconds after that, Elad, our amazing CEO, he opens an issue about it. And then Uri, which we really, really love, he added that issue to the list that we have named Good First Issue.
And I'll, once I get mic'd back, for those of you not familiar with what a good first issue is, it's a label that we put on issues that are ripe for picking for new contributors. So basically kind of when Uri basically labels that issue with it, people can basically say, oh yeah, let's pick this up, let's fix this.
Amazing.
Yeah, thank you.
And it's only getting better. Bear with me. Few minutes later, and I'm not a psycho, but I'll be accurate. 43 minutes later.
I think I have the actual on my, do you mind putting myself on the, great. I have the actual Corey Queen Slack comment. Winglang is some real AWS tier command naming. I mean, come on, wing it. It's freaking there. And then the ticket was
and
open.
then 43 minutes later,
See it in
another community member named Raywan.
Hey, Raywan.
Hey Raywan, we're positive that you're here with us. He was sending a pull request with this feature completed. Isn't it amazing?
It's amazing. It's amazing. You don't have to hit me. And but if you're already
used
hitting
to
me,
it, come
if you're
on.
already hitting me, then it's really amazing. It's also a good opportunity to kind of have a shout out for one of the tools that we're using. We're using orbit.lab. It's a very nice tool, and we want to give them. We're using you, and it allows you to kind of basically kind of get analytics information on your community, either GitHub, Slack, Discord, all the channels, and it's awesome.
Yeah.
It's a great tool to use.
Again, our millions of users.
Yeah, millions of users. Yeah, thank you. Okay, and now as promised, we are about to move to Elad for a code walkthrough. But before, let's take a musical break. We are one and only Mark. Mark, what do you have for us?
Thanks, Eyal. I've had the song Crush by Tessa Violet on repeat recently. I love plenty of genres, but good old catchy pop is always fun, and hopefully you feel the same after hearing it.
I can't focus on what needs to get done. I'm on notice, open digital run. You think I'm tepid, but I'm misdiagnosed. Cause I'm a stalker, I seen all of your posts. You make it difficult to not overthink.
Not now, not now, not now! Wilson. And on this note, we have Elad here on set. Elad, you mind joining us? Thank you, Revital. Thank you very much. You need to take the
Wait a
name.
second.
Okay. Yep. Wilson. What? Oh my God.
What did they do to you?
Yep. I have my tea here.
What's up?
Wow, man. It's I'm glad you're here.
Did you sign up for this?
It all started with a very random discussion with you on some midnight, yeah. And it became a random thing,
Yes,
kind of.
yes.
Yeah.
That's what happens.
Yeah. Yeah. So,
So what are we doing?
so basically, you're here. You have your best friend with you.
My best friend.
This is your computer. I've been borrowing it from you. But so what will you show us today?
So I was thinking, we're just getting started. Millions of users, but still just getting started.
millions
and
of users.
Wing is still not doing a lot besides the
Getting
kind
started.
of the getting started of it.
Yeah.
So I thought maybe we can go through the getting started experience or some version of it, and we can talk about whatever,
Awesome.
ask whatever question,
Awesome.
ask the hard questions.
I'm gonna ask you to explain to me like I'm from the product. You know? That's what I'm gonna do. I know
Yeah.
you wanted this to be the title of the show. But
Yeah.
it might
TBD.
TBD.
Everything's open.
Yeah.
So I guess let's get going.
Okay. So what do we have here?
Wait, I'm gonna delete everything.
Okay. Let's delete everything.
I installed Wing on my machine,
Okay.
so we're not going to go through that. But it's basically a command line tool, the Wing CLI. It's very simple. You can see the little winget here.
Yep.
By the way, I needed to tell you that we don't have to do everything that Corey Queen says. It's actually a pretty dangerous. It could get a bit dangerous. I don't know if you're familiar with his
I've
reputation.
I've started to being familiar with it. You can't put yourself on screen and be ridiculous without kind of
Yes.
starting to get.
We should get him over
Yeah.
to the show probably at some
Yeah.
point. We're shipping Wing as a single executable that includes both the compiler, the CLI, and the SDK.
Got it.
And so you install it, and you get what we call batteries included. One of the ideas of Wing is that the tool chain is going to be very easy to use, won't require a lot of configuration, won't require big project setups. Some of you know, I've been doing Progen, and I have a soft spot for making sure that the tool chain is first class. Definitely lots to go, but at the minimum, it's just a CLI. And we'll just start by writing a little program and see what it does. So, hello, Wingly Weekly. Is that the name?
It's not Wing. It's the Wingly. Hello, the Wing.
Wingly Update.
The Wingly Update.
Because we're not going to do this weekly.
I don't know. Not going to do this.
I think that's going to be pretty. Okay, so we'll start with the simplest ever Wing application.
Vim. Okay.
Yeah,
Interesting.
I mean, just
Okay.
hardcore.
Cool.
And the first sentence is Bring Cloud, and people have been asking us why did we use Bring and not import? And we actually had a pretty interesting conversation about it. I was like, why are we using Bring? We should use import because everybody uses import. And Sep,
Yep.
who owned the design for the spec, was like, you always say we need some soul for the language, and this is adding a little soul, and it's also really easy to identify. You know,
Yeah.
like someone had said, right? Like there's this
The
thing.
first sentence.
The first sentence, it should be easy to understand. And actually, you love this. This is, I think it's like distilling the essence of what we're doing in this sense, right? Like we're bringing the cloud into your code, and so we're gonna. Bring is our import, basically.
Okay, we got Bring Cloud. Okay.
Yeah, so basically Bring Cloud is just, kind of like import the basic library called Cloud. And this is actually completely legal Wing application.
Okay.
It doesn't do a lot, of course.
Yep.
I can compile it. And when I compile Wing programs, I need to decide which target I'm using. But let's add something to this thing because it's still empty. But before I'm adding it, I'm gonna wing it.
Okay, you're gonna wing our low world.
So I'm calling wing it, and what wing it does, it basically starts what we call the wing console.
Okay.
And the wing console is a desktop application. You install it on your machine. It's an Electron application. We're going to release it for Linux and for Mac, for Windows, and it's very, very early with wing console as it is across the entire.
Even more early.
Maybe
than
even
that.
more early to an extent.
Yeah.
And so expect this to change a lot in the next, many years.
Yep.
But the idea of Wing Console is it shows you the contents of your application and it allows you to interact with it as you develop, because that's how I like to develop, right? Like I like to write code and test it. And
so this kind of, a lot of what, even when you talk to me, a lot about this is bringing back the flow. Bring back the kind of, I write software, I'm able to run it, to test it locally. I don't need another person involved. It's all about just fast iteration cycles.
Yeah. That's my obsession, because to me, software, like the whole point of software is that it can change.
Yeah.
And so if you're optimizing for this cycle, you're optimizing for the thing that helps us build software, right? The change, the iterations, the ability to check what you've done. And I think one of the reasons we're building Wing, one of the primary reasons we're building Wing was exactly that. We felt that the development in the cloud has lost its flow.
Yeah. No, I totally relate. It's funny. Originally I studied electrical engineering, and I actually remember the exact point in time when I was sitting at the Technion labs, and I was writing a C++ program. I was compiling it, running it, and I was seeing the output. I said, "What the hell am I doing in electrical engineering? I want to be a software engineer." Yeah, I want to do something. Get the output. Do something. Get the output.
Yeah, and I think it's a very different type of engineering. I think it's important to accept the fact that software engineering is soft. It's about building these imaginary structures in your memory, in your mind, right? And making them a reality. And I think in that sense, it's like a very different type of engineering. Okay,
but right now
it's very empty. It's
okay, so
not really clear what I'm seeing here.
Okay.
So let's go and add a cloud resource to our application, and adding a cloud resources to our application is one of the first things that's unique about Wing, right? Because what we believe is that your code needs to include both your infrastructure and your application code. But to me, the mental model when you're thinking about cloud applications, the entry point, the main of your cloud application is actually your architecture, right? It's not some container or some Lambda function or some,
Got it.
It's this abstract concept, right? Like it's this, when I go and design a cloud application, I first go to a whiteboard and I draw a square and say, okay, this is my application, right?
Yeah.
And so we wanted to make sure that with Wing, this is the experience, because Wing is designed to build cloud applications. It's not designed to run on a single machine.
Right.
And so when I write something here in the kind of like the entry point file of my application, I basically describe the architecture of my application. And so I can say, I want my application to contain a queue. Okay. And as soon as I do this, you see that Wing Console automatically updated, which was the thing that you guys announced earlier for all our millions of Wing Console users that have been eagering for this feature. And you can see this cloud.qu almost.
And a couple of dots.
Because it's very, we're working on that. But there's a queue. I have a queue now. Cool. And I can even go to the queue and I can send a message into the queue. I don't know, it won't do anything because nobody's actually listening to this queue.
Awesome.
But you can start to see kind of like the sketch of what we want Win Console to be. You see these logs here. And so these logs are going to be your distributed log of your application. They're going to show all the activity, all the resources interacted with each other. They're going to show your your logs, all the interactions in through open telemetry events, and so now we just see that this push operation was performed. And okay, so let's do something with this queue. And I'm going to open VS Code now because Vim is.
I was wondering when.
When will that happen? And I think we also wanted to show that we've got the beginning of the sketch of the VS Code extension. So we're building this with the compiler. It's going to be very tightly integrated with the compiler. So the idea is that I don't think that anybody's going to use a programming language without a VS Code extension. So,
the language is strongly typed, so.
This language is already typed. You're going to get code completion for everything and a lot more. And so now let's put this queue somewhere. Let's call it queue.
Okay.
And Wing uses let to see. This is nice.
If you like
AST representations. So Wing.
And who doesn't?
Who doesn't? Yeah, it's true. So we're using let in Wing, and let is kind of like const in JavaScript. So it's basically an immutable type. You can't reassign something.
So by default, it's basically let is const. By default, you shouldn't reassign.
But by default, you can't reassign. And by default, all data in Wing is also immutable. So when you do something like ARR equals 1, 2, 3, you can't change it. It's a read-only and constant variable, and we'll talk in a second why it's important, right? Because it's actually a unique feature. It's an important feature of cloud programming is being able to actually work with immutable data. It's actually very powerful.
So that's something that we're about to see. I mean, I'm writing software, but the software runs in the cloud in different time and different events. So we're gonna see this in a couple of minutes.
Maybe.
Yep. Maybe.
We'll see. I don't know.
Who knows?
Okay. So now I want to process messages that go to the queue.
Okay.
So I do queue dot, and we still don't have code completion. That's going to be soon enough. But there's a function called on message on queue, and I think this is actually it says expected between 1 and 2 arguments, but got 0 when invoking on message, and because.
And what does the on message function accept? I mean,
what do you think it should accept?
It's a good question. I mean,
what would you expect it to accept?
So when a message goes into the queue, I want something to process this message, right?
Exactly.
So I need a processor.
Some kind of handler, right?
Yeah.
And this is just again a sketch for the SDK that is going to contain all these cloud resources, and one of the things that we're building into the SDK is this event-driven programming model. Okay. And initially, it's going to probably be just a bunch of APIs, kind of pattern. But we're thinking of maybe supporting this as first-class citizens of the language.
So you're not starting with kind of having this as a first-class citizen, but the APIs might mature to that.
Yeah. And think about AWS released this thing called pipes at reInvent. Just a few weeks ago, remember?
I remember.
You were there.
I remember
I'm not sure you remember anything.
I remember nothing from
and anything that happens in Vegas stays in Vegas.
A mob of
so
people.
They didn't really release this thing, but
pipes. I remember it.
But think about pipes as a metaphor, as a programming model for event-driven programming, and first-class support in a programming language for that, and things like LINQ, for example, and So there's a lot that we can do in the future, and I think it's an example of why we're building a programming language, right? Because we want to have that flexibility to design the language to support the cloud,
Yeah.
and not vice versa.
Yeah.
I don't know if it's right. Anyway, so the thing that this accepts is a handler, but the handler is going to run in the cloud.
Yeah.
It's not going to run in my machine now.
Yeah.
And so there's this weird thing here, right? Like in traditional programming languages, this would be a closure, right? Like a Lambda closure. But a Lambda closure in JavaScript or TypeScript or C# or Java runs on the same machine.
On the same runtime. Basically.
On the same runtime, on the same machine, in the same process.
Yeah, access to the same
it
memory.
can access the same memory. So if
comes on the same time, pretty much. I mean, yeah.
So we need to express this idea because now we're in the architecture world, and we need to express the idea that this code is going to run inside the cloud, right? Somewhere inside the cloud.
Somewhere else. Yeah.
And that idea is something we call in-flight functions.
Got it.
In flight, you see.
In flight.
You see
yeah. Wing in
yes,
flight.
exactly.
Yeah.
So Yoav's our compiler designer idea. And we love it. Actually, I think it's a beautiful term. And
I love it.
And we call the architecture side, we call it pre-flight.
Yep.
So pre-flight. and
Here you're
in-flight.
writing pre-flight code, but you don't need to state it. It's explicitly.
Yeah, it's implicit.
It's implicit. But the in-flight is what you're going to write.
Yeah, which is, some people would say is the opposite of kind of like regular programming languages in a way. But we think that's the right model because, again, my entry point, the default place I fall into when I start to design a program is this architecture.
Yeah. And it's kind of, once you write more and more kind of quote unquote stateless code, I mean, it's the lines between what is your architecture and what's your code, they all become very, very, very blurry. So this is kind of, I'm writing, this is part of my code, this is part of my application, although this is all infrastructure code.
Exactly.
Okay.
And I think, a lot of people that are in our community right now, they come from CDK, or they come from serverless, or they come from workflows and data engineering, where this is actually the biggest problem, because those domains usually take an incredibly heavy lean on the cloud, right? Like that's where they get a lot of the benefits. And that lean on the cloud is what creates this coupling between the application code and the infrastructure. So we think about the application as the cloud as part of the application and not as an external thing, right? Like, it's just a database. It's not really part of my application.
Yeah, makes sense.
So this is one of the, obviously, Okay, so what are in-flight? Let's start
That's our first in-flight function.
The easiest thing the easiest way to think about in-flights, and this is something that Mark, our infamous DJ, kind of like came up in terms of mental model. I think like a really important coin drop for a lot of us is that basically in-flight functions are async functions.
Yep.
Because, that's what an async function is. It's like something that runs later, right? It's not going to run now, it's going to run later. But they run in a remote isolation boundary, right? Like they're kind of like inter-process or inter-machine async functions.
Makes sense.
And if you think about it, this is how cloud applications work, right? Like there's these distributed systems.
Yeah.
And so every time you run code on a different
Everything is async.
Everything is async, and it's also remote from a machine boundary perspective. And that's probably the biggest reason we're building a new programming language, because this idea of being able to actually create this isolation boundary with the right semantics, with the right constraints that work for the cloud, is something that we couldn't do with like just writing a library, right?
Right.
It's breaking some fundamental assumptions that the compiler has.
But we're also building a language which is very familiar. I mean, it's not that we're building a strange language on top of this. I mean, so some language has that kind of...
Yeah, one version just used emoji initially.
Okay.
Emojis instead of keywords.
So it's a familiar language that takes that topics of the cloud and basically makes them a first-class citizen. Awesome.
Okay, so
what are we going to do in the on
let's do it now.
I'm psyched.
Okay, so basically think about it as a function, right? So it's basically the same as I would write a closure in JavaScript, for example. And I'm just adding an in-flight modifier to it. And specifically, this one takes unknown parser, and that sounds good.
What's wrong?
In flight.
So,
There we go.
So I was supposed to catch this.
You were supposed to catch
Yeah,
it.
not
Or the compiler.
yeah, or the compiler. Mark, let's blame Mark.
Okay, so it's basically, think about it as like, it's the same syntax as an async function, right?
Yeah.
'Cause that's what and now I'm in a different world. Now I'm writing code that runs on the cloud.
Yeah.
And that code has rules, right? In terms of like what it can interact with.
Yeah.
And so it can interact with things like immutable data.
Yep, makes sense.
Right? Because immutable data we can copy, right? Like we can just take this data and copy it to the function.
And we can change it. So because when you change something in in-flight, it won't change outside. So,
Exactly. So if this was mutable, it means that now if I reference it, I don't know exactly at what time this. And the other thing that I can reference, so this is like primitives, arrays, maps, and we actually have dedicated types for mutable
Got it.
versions of these, but those can't be used.
So I can also create an immutable array, immutable. Okay.
Yeah, I think it's also even supported, right? Like it's like mute array.
Yeah, something like that. Yeah, it's supported.
Num.
Okay.
Built-in container mute array is not supported.
Oh, and then you have the.
This is
issue.
what Hassan added.
Yeah.
This is awesome.
Thanks, Hassan.
Why is it not linking? Mark?
Okay.
Okay, so I can also reference resources.
Sure.
And Q is a resource. Now, when I reference this resource and I want to do something on the queue, I can push stuff to the queue, right?
Do we want to push stuff?
No, let's not push stuff. Let's reference a bucket, okay? I'll just create a bucket.
So, I mean, you're using that cloud.
Do you want to push stuff?
To the bucket, to the queue? I mean,
We know exactly what will happen. Everything will explode, basically.
Is that what you want to do? Okay, I'm not sure we have an if statement
to terminate the recursion. So it's just gonna,
Yeah.
the console will just explode
Yeah.
and yeah.
But
We
the
should have probably
interesting
tried.
thing about that print cloud right now, so in C and C++, I have my standard library. I mean, that's so I have stdio, and I work with files, and the standard library for Wing is basically the cloud, right? I mean, the queue, the bucket, and things that you're going to show us.
Yeah.
Okay.
Yeah. And that's obviously almost the most let's say,
It's the most.
it's almost the most important
it
piece
is.
of the project.
Yeah.
And obviously there's going to be a lot of conversation about whether you can actually create a cloud abstraction.
Yeah. So basically, what we're saying, I almost said what you're saying because it's something that comes from you, and you've convinced us really well with this. Is that the clouds have matured enough so we can create the right abstraction for most of the things, or some of the things that you're using. So a queue, a bucket, what are the things that you have in mind?
Topic,
API
service,
gateway,
API, websites.
Yeah.
And I think you know, it's a very interesting, obviously it's a very interesting exercise, and I think that we can get it wrong. There's totally a chance that we will get it wrong. Like when you're designing APIs, there's more art than science to it in some ways. And we've seen people get it wrong in the past. Like it's not the first time someone's trying to create an abstraction for the cloud. And I think timing is definitely, it's definitely important because
it's nice there's more than one cloud. I mean,
for example, don't abstract at the first instance.
Yep, exactly.
But more than that, I think like there's this natural maturation of this programming paradigm called the cloud.
Yeah.
And we've seen this maturation happen in traditional computing as well, right? Like when I used computers when I was, young, when I saved a file, I actually needed to know exactly what type of file system I'm using on my machine, right? Like was it FAT32 or whatever it was? NTFS.
RazorFS. Yeah.
And definitely what operating system I'm using. Yep. And so I had to understand a lot of the layers of the platform that I was using because there was still no abstraction. And slowly we've seen this maturation of the abstraction of a machine, of a computer as a machine, right? Like,
Yeah.
and now when you're developing applications on regular machines, you know you have memory, you have CPU, you have processes, you have a network. Network is a good example. Network is pretty recent, right? Like I'm so old, but I remember when sockets were came up, and that was like this a start of the definition of this abstraction of a network, right? And then suddenly we saw this abstraction exist. API
They created the tuple, and that created the abstraction.
So we've definitely seen this happen in computing before, and I think it's just happening in the cloud.
So when you're creating B here, a new bucket, basically you're not saying whether this is an S3 bucket or whether this is just Google storage or whether this is in my simulator. That's one thing. But you're also not saying whether this is duplicated for multiple regions. I mean, there's a lot of information you're not.
Right.
Can you talk about
the
missing pieces?
And I think that this is the biggest. One of the top questions we get asked is like, but what about all the stuff that's that's different between the providers?
Different and important.
And important, very important. And I think like the way we see it is that. What happened with the cloud is that it evolved from a point where it was basically a bunch of machines in Amazon's warehouse and S3 into and SQS probably. No, SQS was, I think, one of the first for sure. It evolved to a point where typical applications use dozens and hundreds of different services, and so a lot of responsibilities were transferred from the application to infrastructure. And that's a good thing, right? Like that's the power of the cloud. It's the ability to actually hand over some responsibilities on both non-functional concerns like high availability and scalability and network and security and things like that, but also in functional aspects. Because now when AWS has over, I think, 200 services in the provider, and obviously the SaaS ecosystem is huge. A lot of those services, a lot of the resources provide functional benefits to an application. Like a bucket is a functional unit. It's a tool for solving problems, right? Like, okay, I want to put an object on this bucket, or I want to push a message to the queue. And like those are part of my business logic. But they also have a non-functional side. And so one of the things that we realize is that these resources that we're using in the cloud, they basically have two dimensions, right? Like they have this functional dimension, which is actually what applications care about. And they have non-functional dimensions, which is what our DevOps engineers care about. And decoupling those concerns is almost the one most important thing about Wing, right? It's the ability to give application developers the ability to use the functional aspects of the cloud, but use them, not hide them, not make them implicit or implied from the code or no. It's about actually using this infrastructure, but using the functional side of that infrastructure, but still giving the DevOps engineers the ability to apply the non-functional concerns from the bottom. And when I say from the bottom, it's below the abstraction. And so when the DevOps engineers would compile this to AWS, they will be able, we don't have that ability yet, but they will be able to apply non-functional concerns on the output, right?
So they could say that this specific bucket or all the buckets should be stored in a multiple region, versioned and duplicated, and that's it. They have this say. They can do this. Got it. Makes sense.
So it's not that we're not naive to think that we can abstract, create an API that basically allows you to use every cloud provider to its full extent.
Of course.
But we think that we're able to actually define the functional side of those resources sufficiently so that application developers can actually build applications without caring about the non-functional side. So that's the short answer.
Makes sense. And queue and bucket, that makes a lot of sense for them.
Okay, so now let's do something with this thing. I'm going to call b.put.
Okay.
And let's call it hello and just put the string there, right? So it's basically going to create a file called hello.txt on the bucket, and it'll put the string that I put in the queue. So it's kind of like this. And there are a few things to note here. One is this API put. this is what we call the in-flight API of the resource. And we can't see it now because we don't have code completion, but b.put here won't work.
Won't work. Okay.
Or maybe it cannot call in-flight function be put while in pre-flight.
Awesome.
Amazing.
Okay, so we also have the pre-flight. Oh, nice, man.
And so each API, and it's very similar to async functions if you think about it, right? Like I can't call an async function from a non-async context, right? Like I need to be able to await it or to, I mean, I can do it, but it's
doesn't make sense.
It doesn't make a lot of sense. And so in here, it's actually enforced, right? You're not going to be able to interact with a resource without not through its in-flight API. And if you think about it, when in today's cloud, this is basically completely two separate APIs, right? Like even if you're using something like the CDK or Terraform or whatever to build the infrastructure, you have a bucket, right? And that bucket in Terraform is not the same as the bucket that you use to interact with the bucket at runtime, right? Like because you need to basically import the SDK and then create an SDK client, and it's not the same bucket. It's coincidentally called bucket, right? S3 bucket.
But that's what really strikes me. It's code repetition. It's not the same bucket, but if you see it here, you're going to see its counterpart on the other side. You need two different people to work with it. You need someone who's kind of a Terraform expert to set it up here, and you need a backend engineer to do it here. If you have a person in your team that is both, that's great. But if not, then there's
this
you can
impedance mismatch, we say.
Yeah. But in this bucket, what will be kind of the pre-flight API for this bucket, like on update, things like that?
So events. And also functional concerns, like whether it's public, for example.
Got it.
Whether it's public is a functional thing. It has a functional aspect.
Yeah. Whether it's on the edge or not,
probably. Maybe if it's on the edge, it has implications on.
Got it.
So it's not a pure definition, right? Like I think like that's something that it's worth saying. These mechanical aspects of the resources, they leak out to the application, and that's true for regular data structures as well, right? Like when I'm using a hash table in Java, I need to understand that there's a hash code that's used for the keys, right?
Yes.
That's a non-functional aspect of the map. Why are you laughing?
I'm laughing because I was a Java developer.
You loved writing these hash codes, right? Like you loved these like.
I loved all the stories of the hash code
like
of the string.
Yeah.
So what do we have? We have so this is software that even. Oh my God! Look at what you got here. Oh my God! So what do we have here? We have the cloud.q that basically kind of interacts on an on message with.
Okay, so let's see this view. Okay. And again, we're actually working on this view and definitely going to go through some interesting changes. But basically, what we see is we see our application and we see all the resources behind this application. Some of those resources were created for me. Some of them are created explicitly, and some were created for me. And we're actually thinking of like what's the right way to represent them, maybe hide them, maybe not represent them. But you can see the queue in the bucket, and you can also see this function here, which is the function that runs the handler.
Yeah.
And I think it's important to kind of like mention this because the handler itself is not a Lambda function, right? When I wrote here in-flight this thing, I can even assign it to something and handler. So this thing, if I won't call on message,
okay,
you see, so I don't have a function here.
Yeah, there's no cloud function.
There's no cloud function. There's no compute resource for this handler.
Yeah. Very different from the cloud queue or cloud bucket, which exist.
Which are actual physical resource. There's only this thing here that's probably not going to be here.
That's probably going to be
tomorrow.
By the time you check it.
Yeah, like 43 minutes later.
Maybe right now.
Corey Queen.
Refresh the page.
And so before I
okay.
Let me just show you this.
That's good.
If I create a cloud function here, now I have this cloud function. And you can see that it's referencing the bucket. So this is a really
important... Go back to the code because it was pretty fast. Why is it referencing the bucket? We have the cloud function calling the handler, and the handler basically does b.put.
Yeah.
So this is important. This is
magic.
This is huge.
Yeah.
This is. I mean, I spent a day setting the IAM
Spent the
rules.
day with this semicolon.
I mean, I spent the day. I mean, said okay, so I'm not going to do this on the AWS dashboard. Let's do this with CloudFormation, setting the right IAM. I need this function to be able to access only read or only write in this example. I don't know what write is. I need to understand the IAM rules on the specific bucket.
Yeah, but this is still not about permissions, actually.
It's
but,
not.
But I think
your compiler
you're saying, wait a minute, this compiler knows what's going on here.
Yeah.
I think this is exactly the point, right? Like,
So you're saying wait until you show
maybe
me
we'll
this
show
on AWS.
some permissions.
Okay. We don't have a lot
of time.
Okay,
Yeah. What's our time?
Let's move fast.
Let's move faster.
Let's move faster.
We're not. There's no like.
There's no limit.
Audience.
I mean, I don't know.
There is.
Okay. There's audience. Okay.
Okay, but I don't think we have a
We're
hard
good,
stop.
Very good.
So let's call this function. You know what?
Okay.
Before we didn't connect it to the queue, so it's not going to be triggered by the queue, but it's actually running this handler. This handler is putting a file, so we can actually go to this function.
Would you know how to put the message? You wouldn't know. You didn't know how to pass the message?
Let's see. Hello world. Is it going to blow up?
No, it's not going to work. But it's not going to work.
It's going to say success.
Okay, that's nice. That's a start.
And then let's see the bucket. It has a file.
Okay,
here we go.
Let's see what's on the file. Let's download this. You have to click download.
This is very useful.
Yeah, you have to.
And I have to find it. The file.
Yes. I don't know who's that. Okay, it worked, man. Okay, so what did we see?
Skeptic. Oh my God.
Skeptic. What did we see
You're
here?
here to be skeptic.
Yeah, I'm here to be skeptic. This is the cloud function. You send.
I just invoked it.
Yep, just invoked it with a string.
With a string. I didn't even need these.
Yep.
These were redundant.
Yep. And if you go
and you can even see the logs that say that, right? Like I can see
that it was invoked. Yeah. Here.
That it was invoked.
Yep.
And then it says, why is it list? Interesting.
I think.
Oh no! This is
This is the simulator.
Yeah, this is.
Okay, we need to fix this. The fact that it shouldn't.
The simulator is actually
shouldn't
throwing. This is pretty cool, actually.
We shouldn't show the simulator.
Okay, so now let's connect the queue to it and see how this looks when I connect the queue.
Let's
I can remove it.
Yeah, let's keep the handler. That's it. And now we have what we saw before. We have the queue. We have the bucket.
So yeah, now what we see that we have this function that was created by the onMessage API. So that's why it's called onMessage.
Right.
And we can see the relationships between the queue and the function, which is the other side, right? Like it's basically the input.
Yeah.
And we see this thing, and so let's try and do something with the queue and see if that works.
Yep. Let's send a message to the queue.
What should we send? Something from the audience, maybe?
We are here. Okay.
We are here.
Let's
send message.
Okay, let's go back to the bucket. We have the loaded. Let's download this file.
Replace.
Okay, that didn't work.
That didn't work.
No, did you replace the file? Can you open it again?
Wait. You know what? Let's change the name. See that it's.
Yeah, that's going to be better. Great.
I love this reloading thing. Blah blah blah. Blah blah blah. This is always, you kind of make an effort initially,
for me it's always,
and then in the 500 test, it's like A.
For me, it's always
A,
SDA, something with the keyboard. It's always.
Okay, let's see. Bucket. Hello now.
Much better. Download. Save. Blah blah blah. We got it. We got blah 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 on screen.
We got blah blah blah. Yeah. Do we have a second to?
Yeah, I want to show me the counter, right? You're going to show me the
Oh,
counter.
yeah. Let's
I want to see the
counter.
counter. So, because the counter is, I mean, a bucket and a queue, that's kind of, you took a resource and said, this is a resource.
Yeah.
But the counter is kind of different, right? I mean, so what if I do let's see equals new cloud counter?
Let's see.
So
let's see.
Let's see what happened.
Let's see
what happened.
So now I have another resource, cloud counter. If I go, I see it has a value.
Oh.
I can even set the initial value and
that I never checked. Okay, let's see if it works.
See if it works.
Yep, it works.
It works, and it kind of shows this thing called keyword expansion, which is borrowed from Python has a little bit of that, and Ruby, I think, has a little bit of that.
Swift?
Swift, no, I don't think. But the idea is basically that the API behind Cloud Counter takes a set of keyword arguments. And
Counter props, right?
it takes a props. Think about it kind of like the CDK props. And the keys to these arguments become like these keywords. And it's very, very, very nice. Very comfortable. Okay, so the idea of a counter is that counting in the cloud is actually not very easy. Because we're running inside the distributed system, and we have all these race conditions, and we need to save the state. It's actually not a simple thing as, but no provider offers, as far as I know, offers a counter resource because it's like too small, right? Like it's not interesting. And so providers like AWS have counter support in DynamoDB. So like a common practice is to use DynamoDB as an atomic counter, and it has like explicit support for atomic counters. You could use a Redis cluster for that. There are lots of many ways to do that.
It kind of goes back to you were talking about the AWS, but we're running this on the simulator. What are we using for the simulator?
An int.
An int. Okay, and for a bucket, what are we using?
A file system.
Just a file system. And a queue, what are we using?
A queue is an array.
It's an array. So we're implementing a very kind of low budget.
It's like in process, in memory. We took out all the cloud concerns, which is beautiful, right? Like it's kind of like the extreme end of the spectrum on the other side. And suddenly all these resources are really simple, right? Because from a functional perspective, they are simple primitives, right?
Right.
And so implementing them locally is trivial. It's literally trivial, like by the definition of trivial. And so we have a counter, and we can use the counter. We can do stuff with the counter. So let's do this.
Change the file name. It's going to be nicer.
I'll change it. This is like taking it all the way.
No, change the file name for the increment.
Yes, increment.
Oh, you're taking it all the way?
No, I mean
take the increment inside the file name.
Oh, okay, I got it. So let's do value.
So this is nice. I mean, as Mark said, in-flight functions are. I think, why aren't you calling await on the value?
Because we realized that there's no, like in most cases, it's part of like kind of like the design philosophy for Wing, which is always optimized for the common case.
Got it.
And so when you're using async, you're in an in-flight context, in an asynchronous context, and you're calling async functions
all the time.
When have you ever, or maybe?
You've
toyed with the idea.
Sometimes I've done the for loop and then promise.all. Try to understand what's going on there. A lot of mistakes in the middle. The function is it coming back? Promise.all. Never mind. But that's the thing.
And I think this is exactly it, right? Why do we like? I think it's about the evolution of programming languages in a sense. It's like the async monad, like the async keyword was something that was introduced to popular programming languages, I think with C#. C#,
probably.
Sometimes in the
async await. It's the async await.
Yeah, it's async await. I want to say 2015 or something like that. Just throwing it out there.
I think, if you were designing a language for the cloud,
it needs to be async by default, of course, right? Like, why do I have to write await? And so it's not that you cannot use something like promise.all. We actually, we still don't have that supported, but we have in a spec defer.
Right?
And so it's basically just the opposite. So if you want to actually wait for something, if you want to basically defer the execution of an async operation, you just call defer.
So I can still defer and figure out what to do with my policy.
Exactly. So you still get to do this, but probably not.
2012.
Yeah,
2012. Okay. So let's see what this does now. If it's working, it looks pretty adventurous. What's going on here?
No, it's gonna work. I believe.
By the way, the other. This is not. Like this is not syntax highlighted, but all strings in Wing are support substitution. Kind of again going back to evolutions of programming languages and substitutions have been kind of introduced later. So programming language didn't want to hurt performance of like.
Yeah.
But we're building a new programming language. We have
Yeah.
an opportunity to kind of shed some of that legacy that naturally exists in everything that's.
Makes sense.
Okay, so I need to like put something in the queue.
Put a bunch of messages in the queue.
I'm just gonna.
No. Put a bunch of messages in the queue. No, put a bunch of messages in the queue. It's good.
Oh, right,
It's
because
good,
you
it's
wanted
good.
to.
It's good. Just go to the queue, send messages.
Queue. Message 1, send.
Message
2,
2, send. Message 5, send. Okay. Let's go to the bucket. This should be started. Okay, so now we have a low 123, 124, and 125.
Because we started our counter.
Yeah, from an initial 122, probably. Awesome.
I don't know.
Yeah.
We should show the history of the counter.
Yeah, I mean, you probably have this. I mean, in the beginning, but who knows?
Okay,
Who knows?
let's move. Let's move on.
So we have this.
is
The application
not
was
what I
running, and now what do you want to do? We have this running on your local host. The simulator basically proved that your application that basically
Functionally,
take
is
messages, creates a counter, and basically
Yeah.
puts on a bucket different file names. What next?
working. Deploy to the cloud.
Deploy to the cloud. So let's call. Who do we need to call? I mean,
We need to call the compiler.
call
So
the
the
compiler.
compiler is actually executing in the background for Wing console. It takes care of like watching and compiling, and I think that's another example of like some of the cruft that exists today in like tool chains. Like, I need to run my watch here and see the errors there, and run my
we got Uri here. That
like
complain a bunch of stuff.
Okay. So now we're going to call wing compile, and when you call wing compile, you actually need to specify the target.
Sure.
Which I'm not 100% sure about this name yet, but target means like what's the target for this program? Is it going to go to AWS? Is it go to GCP? Is it going to use Terraform? Is it going to use CloudFormation? Is it going to use... So it's kind of like, I like the analogy of like when you're compiling native code and you specify both the architecture and the operating system, the platform. So it's kind of like the same because in our mental model...
The set is the Terraform.
Exactly. The Terraform or CloudFormation or Kubernetes or Pulumi are the instruction sets of the cloud. Because I can go and actually install them on my machine called the cloud, right? SIM is another output, and then the AWS, GCP, Azure are the operating system.
Makes sense.
So that's the analogy. So we're going to compile it to the only target we currently support, which is Terraform AWS.
We support SIM as well, not the
And
only one.
SIM.
Okay.
But we're going to use Terraform AWS. And we actually have some work on GCP support for Bucket, I think, going. And like we don't intend to like just support AWS for like 3 years before we start supporting other. Like it's actually an important piece of the story. And so as I've compiled it, and I know it's not as fast as we want it to be yet.
I saw you. I saw you thinking about this while it's loading. What's going on?
You know me too well already. So this is not what I wanted.
You need to go back.
Yeah, here. So basically, we got this target directory, and it has a cdk.out file, a directory. We're probably going to clean that up a little bit. And here, there's a cdktf JSON file.
So you write your program in Wing. At one point, you compiled it we haven't seen all the compilation, but you compiled it and ran it to the simulator. Now you're compiling and running it into Terraform AWS. And the assets, the artifacts that the compiler created is what? A Terraform file?
Let's see. A Terraform file.
Okay.
Which is basically something that I can go and deploy on AWS.
Okay.
And if you look at the resources, we have Lambda functions, we have buckets, we have the queue, we have a DynamoDB table, which takes care of the counter. And it contains the runtime code for the specific resources. And so in this case, this is a Lambda archive. This is something that can run on a Lambda function.
And what language inside that archive?
It's Node.js, JavaScript.
Node.js, JavaScript. Got it.
And
so you compiled it, in this example, you compiled it to JavaScript and Terraform.
Yes. And this is also a degree of freedom that we're considering for the future. Maybe we'll be able to compile to WebAssembly. or to other programming languages. It doesn't necessarily mean that we will continue to compile to JavaScript. But it's definitely an amazing ecosystem to tap into, and this is the idea, right? Like the idea is that when you're compiling to JavaScript, you can tap into the NPM ecosystem.
So we're starting a new language, but we'll be able to tap into the existing ecosystem.
Exactly. Okay, Terraform. Init. I'm gonna try to do it. It's probably not gonna work.
Yeah, why not?
Who knows? We've never tried this application, right? Like
This
this is the thing, right? Like it's alpha, very early alpha. If you're treading in the path that we've tested, it's gonna probably work.
Yeah.
There's a chance it won't work in the other path.
You have to really work on those
On
yellow
my-
micro.
Okay, Terraform apply. And it's pretty extensive. And by the way, this is how you do this. Like this is how you need to write this application in AWS. This is the best practice. Anything else is probably, you can do it in many ways, but you're going to lose scalability. You're going to create deadlock, race conditions. There's so many concerns.
You're going to have too many permissive permissions.
The permissions are going to be tight. We haven't seen the permissions, by the way, but I think like that's definitely worth. Look at the policy for the. Wait. So we have the policy. Yeah, the policy for the Lambda function. And so you can see the policy here. It's actually not super easy to read. Let's. This is my way of parsing JSON. Or it's supposed to be console log. Oppa, sorry.
Okay.
No.
To null. You have to do. No, you have to do JSON parse.
Oh, I know what
JSON parse 2 and null.
JSON parse.
S null 2. S null 2.
Oh.
Okay. Nice. Yeah, something like that. Okay. Again.
So easy. The easy way. That's called the well-lit path to showing a JSON thing.
Yeah. What are we seeing here?
We're seeing the IAM policy of the Lambda function.
Okay.
And this is what you said earlier, right, about the connection. So you can see that we've got access. I can access this bucket, in these paths with these actions.
Yep.
So it means that I can put stuff on the bucket. It means that I can get stuff from the bucket, and delete stuff from the bucket. And I think this is actually one of the things that currently our compiler doesn't have the full model for analyzing the permissions that you need to do to access. But this is actually something that we're working on, and I hope that it's going to be available in like.
So what you're saying right now, our compiler basically asks for too much permissions, but that's something we're going to fix.
Yes,
But
exactly.
the idea is for it to ask only.
And we're going to announce it on your show.
Yeah. Okay. On our show.
It's going to be a big thing. But we can also see that it's updating an item on the database, which is the counter, and this is the permissions that it needs in order to receive stuff from the queue.
Something anyone would just write very easily.
Very easily, just on top of my head, this is the ChatGPT. Create all this.
Exactly.
Okay, we should have probably started the deployment earlier, but it's not going to take too long. I think most of the resources here are, and we'll try to see if it works.
Yeah.
What did we need to put stuff on the queue and check if it goes into the bucket. Okay.
That's what we need to do. It starts with 122, I think, right? The initial value.
Okay.
Okay.
So what's up? What's up?
What about Wilson? What do you think about Wilson? This guy is.
Yeah, you should tell the story at some point.
What's the story? I don't even remember.
The story is that we got this meeting owl.
Yeah. Okay.
For talking to all our folks remotely, and we would like just upgrade the experience.
Yep.
We used it once.
Yep.
And since then, it became the mascot for.
He came to us to one of our offsites.
And he comes to every offsite.
Yeah, I mean, like me, only to the second one.
Okay, deployment completed.
Okay.
I'm gonna go here. I've got the bucket, I think. I don't know which one of those.
Yeah, okay.
But based on the creation date, it's supposed to be this one, right? So it's empty.
It's empty.
Oh no, that's
this
actually
is,
the.
So that's the bucket that holds. I mean, this is details that that are hidden for you. This bucket holds the archive lambda.
Exactly, the lambda code.
Yeah.
And this one's empty. Great, empty bucket.
Empty bucket.
Good job. And now
Let's create another.
I'm gonna go to the lambda. We'll
To the queue.
I'll go to the lambda function and to the queue, right? And so.
Go to the lambda function.
I think it's. I think we're in. Wait, which
Europe.
region?
Where are you? Why are you?
Which region? EU West 2.
Okay.
Yeah, I'm trying to stay close.
Okay.
EU West 2.
Really, you're trying to? What?
It's closer.
Okay. What are you optimizing here?
I'm optimizing for iteration cycles.
Okay.
Okay, so we've got the queue here. We've got the message, the unmessage. Okay, cool.
Okay.
And we've got this queue here.
Yep.
And these names are going to be fixed. Don't worry about it. It's I think there's a discussion even going.
There is a discussion.
Send and receive messages.
Send us a message, and we're gonna send a message. We're gonna send more than one, right?
Let's do it.
Send this
One.
message, and now send another message.
2.
How is it gonna work? Oh my God.
Wow, if it's going to work.
We never tried this.
We've never tried it. Okay.
And there's a new feature here that was released today in the compiler, the add the implicit await.
Right,
So it's,
right. It's very experimental.
It's very
It's
experimental.
cutting edge.
It's not gonna work.
It's not working.
But we tried.
We definitely did. I mean, I can open the logs and see if it's
Yeah, but
interesting.
that's going to be interesting.
That's
only,
cheating.
That's going to be interesting only for you right now. I mean, we're not going to look at you.
No, I'm sure it's going to be interesting
let's
for
look at
everyone.
this.
We'll see some invocations.
So I suggest you open a ticket about this. This is a bug. Why is this is
It
not
is.
working for us?
Okay, we'll figure it out.
Yeah, maybe it's the wrong bucket. Anyhow, why? What? No, it's the right bucket. We were close, man.
Yeah.
We were close. So ring is
Next
still
time.
young.
It's still young.
Next time. And wow, this was super interesting, man. It was fun talking to you. Okay. Thank you. So we were inside. We kind of lost track of time. We were supposed to have that.
As usual.
Yeah,
as usual.
we have to talk about wire language. We're not going to have this today. But we will have to reschedule this for next time. I'm sure we're going to have it. So I want to thank you all, Wingats here and across the world. Vital, Shiri, Elad, Shai, Mark, and special thanks to Video Power Production, guys, for enabling this and having fun with us. Thank you all. So, Merry Christmas.
Merry Christmas.
We're back online.
We were
just kind of congratulating each other, hugging and everything, and then
Crying a little bit.
Why didn't it work? Damn it! Why didn't it work? And then you hit the refresh, and can you see this on screen? This computer?
There we go.
I mean, we the files were actually created.
Dare I open this? Dare I open this? Sorry.
Yeah, open this. Open this. Maybe we shouldn't open this because I mean it worked. Yes, it worked. Let's do like woo! There's still a bug here. It duplicated the message. I'm not sure, but we're close. Maybe we won't call you again. Thank you, everyone. Thank you. Bye.
Thank you. We're done. We're finished.
You forgot the weight.
You forgot the way.
I forgot the way.